All right, it is currently February 3rd, Wednesday. This is CS-030, broadcasting on YouTube and broadcasting in game. Got broadcasting in game. Now going into Inception mode. In game. Now going into Inception. All right, and let's see if I can fix that. Okay, hopefully Inception ended. Let's see, Matthew, I see you there sitting in front of me. How is the screen working for you? Matthew's disappeared. Landon, you're over on the right. Is YouTube broadcasting?
Right now I just see like a the class 9 lecture.
Okay.
And not the live stream.
All right, let's see if we can adjust class 10. All right. There you go. Let me know when it's working. It's going to go Inception mode in a second. There you go. Let me know when it's working. Let me know when it's working. Inception mode. Inception mode. There you go. Let me know when it's working. Let me know when it's working. Inception mode. Inception mode. There you go. Let me know when it's working. Let me know when it's working. Inception mode. Inception mode. There you go. Let me know when it's working. How's that?
Yeah, that's okay.
Okay, great. All right, here we are. Let me turn down our music for a sec. Let's arrive for a moment. Let's just take 10 seconds and say a prayer to center ourselves and to remind ourselves of what we're doing as the technology settles down a bit. Go back to title screen. Just join me in prayer for a sec. Dear Heavenly Father, as we get our tools organized to try and learn, help us to settle in, help our brains to calm down, at least my brain. Help us to learn so that we may apply so we may be good stewards of the faculties and abilities that you've given us, that we can build your kingdom well. Amen. All right, so here we are. Let's run through our checklist real quick to make sure that everything's going okay. And I'm going to I'm going to walk over there for a sec to walk through it, and you can listen or walk over if you'd like. Yep. Total Inception mode. All right, I'm heading over to the checklist. I updated the checklist. It's just sort of a minor change, but still helpful. Okay, so first of all, find a quiet location if you're not already there. Let your roommate know that you're in class. They'll need to know so that they can shut down their industrial cement production while you're in class. Put on headphones so you don't get the endless echo, akin to what we just had with Inception, but for different reasons. Turn off notifications on your phone and computer. I got to do that on my phone here. Good. I'm all notificationed down. Shut down any extra apps or browsers that you've got going. Your Fortnite championship, that's on the other. Sorry for double audio. The Fortnite championship that's going on in the other window. Shut that down for the purposes of class. Get a Canvas window open so you can track with what we're doing today. And let's see, then go ahead and open Eclipse and connect to Saros via the OpenFire account. Activate your VPN if you haven't already, and open Firestorm. That was part of the problem that I had this morning with coming and going. My network was glitching on my side. Rebake your avatar by going under Avatar and Avatar Health and doing Rebake. And then go under Environment and set your environment to midday so we all look like we're in daylight. Set your draw distance to a low number. I've got mine at 168 for the purposes of class. Make sure you can see your classmates' names. And then let's do a quick rundown. Let's do a quick audio check by doing just a attendance check. So what I'm going to do is I'm going to call out your name, and if you could unmute and just say your name again and then here so that I know who's talking. And to get that set up, I'm going to pop open a gradebook window, and we'll take it from there. Say music, hide our music. Today is class 10. It is Wednesday. I was very confused last night because of the holiday. I thought today might be Sunday. Very, very confused. Okay, class 10, great. All right, so Landon, Ben, or Ethan Banez?
Landon is here.
Ben is here. Ethan's here too.
Thank you. Taylor, Carson, Dee, or Ben D?
I'm here. This is Carson.
Dee is here.
Okay, you got Carson and Dee. All right, looking for Trent, Josh, or Ben Fernberg?
Ben here.
Matthew, Morgan, or Thomas?
Josh Fitz is here.
Sam, Monty, or
Morgan
Frank?
is
Matthew
here.
is here.
And Adeline, Toby, or Faith?
Sam is here.
Monty is here.
Adeline is here.
And Ethan,
Faith
Vaughn.
is here. Faith is here.
Okay, quick
I'm here, Ethan.
quick rundown of the people I didn't hear. Toby, Frank, Thomas, Ben D, and Taylor. If you're here, speak up.
I'm here. I just had to use the restroom real quick.
Who are you?
Thomas is here.
Ben Douglas.
Okay, got Thomas and Ben. Okay, good. That's ironed out. You'll see that in Canvas in a second. All right, next thing to bring your attention to is I've been grading the second problem set. And so over here on the rack, I've added them to the solution set. So on the bottom row are solutions for 1, and on the second row here are solutions for 2. We've got the half-size picture and the die simulator. If you want to grab that, you're welcome to grab that. Let me throw some of those solutions up and we can talk about them for a little bit. I haven't finished grading them all yet, so no one's seen their grades yet, but I'm about halfway done, so I feel comfortable going over it. So now I'm going to switch to Eclipse on the bottom screen and should be broadcasting that. Let's find Eclipse. Eclipse, where'd you go? There we go, and let's not show everyone's code. Sorry about that. All right. And so I'm not doing Saros right now. I'm just showing you some solutions and some things that went well and things that didn't go well. All right, so on the screen, I'm going to switch to a zoom in of the code. There we go. And so what we're looking at now is we're looking at a potential solution to the first one, which was the die simulator. Let me run through some of the different issues that we had that were good and bad. Let's see. So one of the first things to do is to make sure that you have a header on every single file that you turn in. And in that header, it should have something about what's in this file, like what problem you're working on, your author, who you are as an author, and possibly if you're working in a pair, 2 people. And it should also have the date in your case for the date at which you're working on it. This isn't just about me and my class policies. This is something that you'll do on every single software package that you turn in because managing intellectual property rights is very important. And one of the ways in which intellectual property rights is managed is through the header blocks in these code in the code files. So you'll put who the original author was, and then over time it'll edit and change. But that's very important for various kinds of copyright law and whatnot. My dad, for example, had a company for many years before he retired, and he had an employee who started working for him and brought code from his previous company. And my dad's company got sued for like $100 million or something for using source code that wasn't that he didn't have rights to, even though he had nothing to do with it. The employee just started using it. So keeping track of those things is big money and big business. So it's good to get in the habit of it right now when all that matters is keeping track of it for your assignment. Line 1, we've got our package. You got to make sure you include a package. When you include a package, over on the left, what you'll see that Eclipse will put your package in a directory structure, will put your file in a directory structure that matches what it is that you typed in. So here's my die simulator, and you can see that it follows down, starting at my source folder, goes through edu.westmont, and then ends up in CS-030, which is equivalent to what's up here. If you don't put anything up here for package, what you'll see over in your package explorer is something that says default package. And while that's fine for getting things going, it's not a good way to manage your software generally. You want to put it in packages specifically, and in this case, in Java language, package basically means folder or directory. Import, that should be pretty straightforward. We've got a class called Die Simulator. A couple things about this. You just got to make sure it's called Die Simulator. That was part of the requirements. Some of you named it E212 or something. The requirements asked for Die Simulator. Make sure it's capitalized. Down here, when we were doing our doing the code, most people kind of got this more or less. I think the trick was to recognize that next int 6 will give you a number between 0 and 5. So to get a number between 1 and 6, the most efficient way to do that is to just add a 1 to that. One thing about comments, I have done a good job of instilling in you the benefits of writing comments. However, maybe I've done too good a job because a lot of you were writing a lot of comments for code at this level. A couple points on that. The people that are reading your comments know Java. And so it's not necessary to write out a line that is exactly what your code is doing. So for example, if I were to put a line here that says, create a variable called R by calling the constructor for random. That comment, while accurate, doesn't help a whole lot for someone that's reading the code, because if you know Java, that provides everything that you need to know right here. What is very helpful for something at this scope is to have a comment above main, or to have a comment up here at the top of the class, which describes overall what you're trying to do. And so something like this program outputs one random number between 1 and 6 inclusive, is kind of the sweet spot for this example of code. It describes everything that's in the code. It talks about intention and semantics for what you're trying to accomplish through this code, but it doesn't overload every line with another description of what you're doing, because the code itself, of course, is the ultimate comment. Code is precise, and so in some ways it comments itself because what it does is what it says it does. But people sometimes need some understanding of what you're trying to do with the code, and so some higher level bits of code are more important. So that's Die Simulator. Any questions about that one, or how I approached that one, or any concerns about that? You'll get more feedback when I release the grades. I've got about 5 more groups to do, or 5 more individuals. All right, I'll go on to the next one, and if you do have a question, pipe up, because the lag is making it a little bit awkward. All right, similar thing with half-size picture. Let's see, a couple points on this. Same concerns about making sure you have a good package, making sure that your class name is capitalized and matches your file name and is accordance to specification. Make sure you have a header comment. Make sure that you have a name in there. Things along here. Some of you, when you did pick load, what you provided was a file and sometimes a specific path name on your hard drive. So one thing that you have to remember is you have to put yourself in the mind of the user of your code. A lot of different kinds of users. You might have API programmers, or you might have non-technical people who are running your program as if they're just using it as a tool. You may also have me. I'm also one of your consumers of your code as someone who's grading your code. So if in this pick load command, you put in a file name and then you pass it over to me to grade, the code doesn't work for me because I don't have that file on my hard drive available for me to load up. Especially if you put some kind of path name that specified a path on your hard drive that was unique to your computer because it contained your username, that code won't run for me. So in this case, the best option is to include the URL as the thing that you are loading, because when you include a URL, what you're communicating is that the file is located on the network. And so by doing pick.load with a URL, following the conventions of the load method, what's going to happen is my computer is going to go out, it's going to reach out into the server on the internet, grab that picture, and bring it back for presenting. The upside is that it will work pretty universally on anyone who's running this code on a computer that's connected to the internet. The downside is that it takes a brief moment for the network to respond and get your picture back. So initially when you load your image, it'll be a small window and then it'll pop up as it arrives. New width and new height. Most of you tracked this down. The main thing that I saw going wrong in this case is that some people use what I call magic numbers. I'm not the only one that calls it magic numbers. Magic numbers would be where you have a number in here that doesn't have any particular explanation. So for example, if I'd done pick move 240, 240, it turns out that 240 is in fact 1/4 of the size of the image that I'm loading on line 14. But the problem is that 240 doesn't make any sense to someone who's looking at this code. And if you decided in line 14 to load a different image, 240 wouldn't work anymore because that different image might not be 240. So instead of using magic numbers, in this case 240 is a magic number, it's a number that doesn't have any explanation or any context. What's better is to generate that number in whatever way it was that you arrived at it. So somehow you came up with the number 240. So a better solution is to put that calculation into your code directly so that your code is more resilient to other images that you might load. And the semantics of what it is you're doing is represented more mathematically so that it will work in more situations. Code like this that I currently have on line 18 is going to work even if I change the picture that I'm loading. It's always going to be 1/4 and it's going to show up in the middle. A few of you had a little bit of reasonable confusion about what it means to center an image, especially or what it means to do half size an image. Because on the one side, on the one case, you could imagine that half size image means dividing the width and the height by 2. But another way you could imagine it is that you want to present your image with half the area instead of half the width and height. If you presented your image with half the area, then the width would be greater than half because as it is now, we have 1/4 of the area. If you ever run into confusions about the specifications in a situation like that, you will do a small version of what you would do professionally. Professionally, if you ever didn't understand your requirements, you would go back to the person who delivered the requirements to you and you would ask them for clarification. If you're working in a software engineering firm, that probably means going to your boss who gave you the requirements of what it is you're working on. In some cases, if you're in a more entrepreneurial or startup environment, you might go out to an external client and say, hey, what exactly did you mean when you said load a spiral image at half size? Did you really mean spiral image or did you mean any image? And when you said half size, did you mean half the area or half the width and height? Requirements are never perfect. You always need to get clarification. So if you run into that situation, please drop me a line on Slack or something. We can clarify what it is that I meant exactly. All right, so there's example. You can grab a copy of those solutions if you'd like from in World. Let me just make sure that we don't have any other questions. First, give you a second to comment. Okay. I have been adjusting the schedule a little bit. And the reason why I have been adjusting the schedule a little bit is because people seem to be doing quite well and tracking what we're doing. And I don't want to belabor some of the more straightforward parts of Java that translate really well from Python. And instead, I would like to spend some time on some higher level issues, higher level programming concepts that we get to later in the class. And so to that end, I've adjusted the schedule a little bit. And if you were tracking weeks in advance your commitments, they've adjusted a little bit. And it's not quite ironed out. I'm still trying to figure out how the last month of the course is going to go given our current schedule. So keep an eye on Canvas. Things should be okay for the next few days. But what I'm immediate concern is that we're going to start on chapter 4 today. Let me see if I can bring that up for us. Chapter 4 is about fundamental data types, some of the things that we've been using already. Let's look at our calendar to orient ourselves and make sure it's refreshed. Let me make sure we're looking at today. All right, so today is the 3rd. You have a Chapter 3 Techne due tonight and a Chapter 3 Programming Assignment due Friday. Chapter 4 we were going to cover in 3 lectures, and instead we're going to cover it in 2 lectures, but we're not going to do a programming assignment associated with it. We're just going to do a Techne associated with it. I think that's sufficient. So we'll be covering Chapter 4 today and Friday. You'll have an exam a week from Friday during this time period. It'll be online through Canvas. And that exam will cover up through and including Chapter 4. It will not include Chapter 5, although we will be talking about Chapter 5 before the exam. Let me see if there are any questions about this scary exam that I just pointed out.
Professor Patterson.
Yeah. Let me switch to game so we don't have lag.
Are you going to hold us accountable for knowing all of the graphic design content in the chapters?
Switching to in-game response for a sec. All right, broadcasting in YouTube again, if all is going well. Wow, that's too big. Why did that go so big? Do not know. Whenever this happens, my daughter says I'm a boomer. Okay, whenever the computers don't work. And then she tries to use my computers and it doesn't work for her either, and everyone laughs It's a great sitcom moment when it turns out I'm not the boomer after all. It was the okay. Fundamental data types, chapter 4. What we're looking at here is looking at those primitive data types that are associated with Java's historical trajectory. Things like int and, oh, I'm double broadcasting again, sorry. I hear all the typing and then I know what I'm doing. Okay, thanks for keeping me honest. All right, and sorry, that threw off my game here. One second, I'm monkeying with my window. There, perfect. Okay, we got it set. We're broadcasting. We're good. All right, super. All right, fundamental data types. Here we go. All right, so what we want to do is make sure we know how to represent integers and floating point numbers in our Java environment. We want to remind ourselves about the limitations of numeric types that cause overflow and underflow errors. We want to be aware of the proper use of constants and how we do arithmetic in Java. And then introduce ourselves to the string type and sort of get ourselves up and rolling with these basic ways of using some of our structures. So the first thing that we start with is we start with our number types. So we've got a couple number types that we work with. It is going to be we can either represent it as a primitive type or as a object. But what we're talking about today are primitive types. There are 4 integer types that are primitive and 2 floating point types that are primitive and 2 other kinds of primitive types that I want to introduce you to. So let me just give you a second to digest that. There are not an infinite number of primitive types. You can't make up new primitive types. They're just primitive types that sort of came with our language. And they represent primarily numbers, but also a few other small things. All right, so we just need to be familiar with them, and we need to know how they work. All right. So here are our primitive types: 1, 2, 3, 4, 5, 6, 7, 8. And what I want to draw your attention to are the 2 most important ones for starters. The 2 most important ones are int, which is an integer, and double, which is a floating point number. That's going to dominate probably 75% of the primitive types that you're going to see. The next one to focus on would be Boolean. Those are things that are true and false. Now, each one of these data types, they all have zeros and ones that are stored in the computer, that the data type tells the computer how to interpret those zeros and ones. When you have an integer type, an int type, int, there are 4 bytes assigned in the computer to represent that integer type. 4 bytes is 4 sets of 8 bits. 1 byte is 8 bits. So if you have 4 bytes, you have a total of 32 bits. You take those 32 bits and you interpret them as an integer using a style called 2's complement representation. If we interpret those 32 bits as an integer, we can represent the numbers from minus 2,147,483,648 up to and including 2,147,483,647. You'll notice it's not exactly the same in terms of the number range. It goes to the end here is 648 and the upper end here is 647. That's because we have 0 in there as well. And so there are the same number of numbers between 0 and the upper end as there are from -1 and the bottom end. And that is the total number of numbers that we can represent as integers within 4 bytes. In contrast, a double uses twice as much storage. Instead of using 32 bits, 4 times 8, we use 64 bits, or 8 times 8. And with those 64 bits, we represent our number in a different way. We don't use 2's complement. We use something called the IEEE, I think it's 304 standard. And when we do this, we're able to represent floating point numbers, or numbers that have a decimal component in them. And we can represent numbers from about plus or minus 10 to the 308th power, a really, really large number. Kind of doesn't have any physical meaning because I don't think there are that many like atoms in the universe, but useful for math of various kinds. Doubles are represented differently than integers. They are not, of course, continuous because floating point numbers can be infinitely precise, and computers can't do that because they only have 8 bytes to work with a double. Finally, when we have a Boolean, we have a type that either has true or false, and we are able to represent this in a very compact amount of space, in fact, just 1 bit. Notice that's 1 bit, not 1 byte. So it's not 8 bits, it's 1 bit. This is standard across Java. This has been standardized so that all Java virtual machines are going to use these particular sizes. Now, if we fill in between there, we can see we have some other kinds of integers. We have int, we have byte, we have short, we have long. And these are all characterized by the number of bits that are going to be used to represent the integer that goes with it. So if we have a particularly large integer that we'd like to use, we can use the long type. This is going to be an integer that uses 8 bytes, and as a result, we can get higher numbers on the high end and lower numbers on the low end that have much greater magnitude. If we want to use less storage and we don't need the capacity of the integer to go higher than 32,767 or 8 on the negative side, we can use a short. The only reason we would want to use a short is because we're trying to save space for some reason. And then finally, we can go even smaller and just use 1 byte, in which case we can only represent the numbers from -128 to 127. So in these four types, you have the ability to represent integers with a smaller or greater magnitude capacity based on how much size we allocate for them. Most of the time, you're going to use int. Likewise, you can use a double or a float to represent floating point numbers. Floats aren't as precise. They don't go as large and they don't have as much fractional component to represent them. Less space. 90% of the time, you're going to use double. Char finally is a character type, and it requires 2 bytes in order to represent 1 character. So a string is composed of characters, and it takes 2 bytes to represent 1 character because we allow our characters to not just be English characters, but we also allow them to be glyphs from other languages. For example, Korean or Sanskrit, Farsi, any language that uses non-Roman glyphs, or even things like enyes or umlauts that are kind of based in Roman characters but have additional accents to them. That requires a total of 2 bytes in order to encode them. All right, so these are our different primitive types. And fun note about this, I don't know if you're familiar with Gangnam Style, the video by Psy that made the rounds a couple years ago. YouTube at that time used a int in order to represent the number of views that a given video has. And Gangnam Style was the first video that had more views than what they could represent in this integer. It had more than 2 billion views. And so for a brief while, Gangnam Style broke YouTube, not the whole internet, but broke YouTube because the number maxed out. When someone would view it, they tried to increment this counter and it couldn't have any more capacity. So over the month or so following the release of Gangnam Style, they had to upgrade the view counter from being an int type to being a long type so that they could capture the true number of views that a particular video has seen. Since then, there have been a number of videos that have been seen much more than Gangnam Style, but the capacity is so much greater that it's unlikely that they're going to hit the limit of that anytime soon, unless people start watching the video like 1,000 times at once on all of their Internet of Things devices or something. I don't know what that'd be like. Okay, those are our primitive types. Any questions or comments about that? I'm looking in chat. Okay, yeah, go ahead. Yeah, good question. I'll answer on YouTube. So the question is, if unless you're constrained by space, is there any reason to not use the bigger data types? No. If you've got space, you can use the bigger data types, especially since most computers are 64-bit operating systems now. They can handle the 64-bit types, so like a long and a double use 64 bits. It is parity matched with the, oh, sorry, you can't, I didn't realize my face was on top of those. That's no good. That's parity matched with the operating system, and so it is a good option for if you want. If you're not trying to save space, it doesn't matter. I mean, the thing that happens is maybe you suddenly want, an array of a million integers, and now all of a sudden you're talking about kind of a lot of storage space, and so you worry about it when you start dealing with a lot of data at one time. All right, that table's from your book if you need to review it because my face was on top of it. Sorry about that. All right, so a number literal is a number that occurs in your code. You can have literals of all kinds, and this is when you actually type in the number. And it's just the way that you represent it with characters in your source code. If it has a decimal, it is treated as a floating point by Java. The Java virtual machine assumes that it's a floating point. And if it doesn't have a decimal, it's assumed to be an integer when it's compiled into your code. So here are some examples of that. We have the number 6. This is considered to be an int as a literal. It's an int. Java thinks it's an int. -6 is an int as well. 0 is an int. But 0.5 is considered a double. And notice that by default, Java uses double as the default floating point primitive type that it uses to represent floating point numbers. 1.0 is a double. You can represent them in scientific notation. For example, here, 1e to the 6th means 1 times 10 to the 6th, or 1 million. That's considered a double. And you can have fractional bits like that. So 2.96 times 10 to the minus 2 ends up being 0.096 if you want to represent it in scientific notation instead of as 0.0296. If you want your integer to be treated by Eclipse as treated as Java and Eclipse as being not an int but a long, because you want that higher capacity, you have to put a capital L at the end of your number literal. And when you do that, then Eclipse will treat it as a long. You cannot put commas in your code. We're used to using commas maybe in spreadsheets or sometimes when we're communicating it to other humans in a PowerPoint deck or something. If you put a comma in your code, Java doesn't understand that to be part of a number, so you'll get an error. However, you can use an underscore instead of a comma, which is a little bit of a quirky thing about Java. But if you want to be able to try and separate out where the zeros are blocked into powers of 1,000, you can use an underscore. You can't use fractional representation. So you can't do something like this, 3 space 1 divided by 2 to represent 3.5. Instead, you have to use a decimal notation like 3.5. Let's just look at Eclipse real quick and take a look at what that looks like if we try and work with some of those numbers. So I've got I'm not going to share on Saros right now, but I'm just going to create a new class within my package for today called demo, just to show you what happens here when we're working in the code. So I have a main function. I'm using the default package. I'm not turning it in. And we can just make some types here. And then we can assign them some values. So we can say A equals 5. 5 is considered an integer. B equals 5.0. 5.0 is considered a double. C equals true. And you can see true gets highlighted to represent the fact that it is a reserved word. And then C only uses 1 byte. So let's do a long. If we do something like that and we say AA equals 5, we should get a little warning. Do we get a warning? Oh, that's going to get upgraded to a long for us automatically. Better process there is to do an L. There are various, oh yeah. Okay, so as a primitive type, that's not a problem. In other cases, if we don't use a primitive types, we'll run into some trouble. We can use a less precise floating point if we want. And there's not really any other kind of double Boolean to use. What happened here? That's interesting. There we go. All right, so just like we have to specify if we want an integer interpreted as a long, we also have to add an F if we want a floating point to be interpreted as a float instead of a double. So a couple, yeah, that's just using it. That's what it looks like in practice. Any questions about that? All right. So overflow. Here's a picture of a soda overflowing. Oh yeah. Can you ask that again? testing. All right. Rounding errors occur when we have a floating point number that we want to represent, but we can't represent it with our computer because there's a limit to what we can represent in our computer. Floating point numbers therefore have limited precision, and we can't represent every number precisely, so we get some round-off errors. Here's an example of what you could get as a round-off error. You could try and represent 4.35 exactly, and then you could multiply it times 100, and you wouldn't get the exact answer. You get an approximate answer. The root of this problem comes from the fact that computers keep track of numbers in binary form, and when we type in literal numbers, we type in decimal numbers. So we use a base 10 system when we're typing into source code, but the computer natively uses a base 2 system. And you can't represent all base 10 fractional numbers exactly in base 2. So the computer does the best it can in representing a number and a double that is as close as possible to what you wanted. Integers, however, can be represented exactly both in decimal and in binary, so you don't have the same problem. We go into great depth about this in CS-45. If you're ever interested in knowing more about number representations, that's a big part of what we do in CS-45. All right, so the bottom line is we're going to use double in almost all cases. All right, one of the ways that we can decorate some of our primitive types is we can decorate it with the reserved word final. And what final does is it enforces that a number is a constant. If you'll recall within Python, we sometimes used this kind of capitalization and snake case in order to convey that what we intended was for something to be a constant. In this case, quarter value is 0.25, the value of a quarter. In Java, we're able to enforce that in the language. So by putting the word final in front of it, what that says is that the code isn't allowed to change the value of quarter value anywhere else in the code. It gets one value, it is set at the beginning, and it may never change again. And that's really helpful for making sure that you don't have errors in your code, and it also enables Java to do more elaborate static processing of your code to make sure you don't have errors in your code, for example. So we still use that representation. We use capital letters and we use underscores between words if we want to represent multiple words in our variable name. And that communicates to a programmer that what we're looking at is a constant. That communicates to the programmer that it's a constant, but the way that we enforce it to be a constant is by using the decorator final on our variable. Once it's set, it can't be changed anywhere else in the code. That's really helpful sometimes. All right, great. Okay, sometimes there are some numbers that we would like to use as constants that are going to be used in a lot of different places in our code. And so we can decorate it with another decorator. And the other decorator is static. And what static means is that it is a variable that anyone can, well, public means that anyone can use it. Static means that there's one copy of it for all objects, all math objects in this case. So rather than creating a new instance of our variable e every time we call the new command in our reserved word, there will only ever be one version of the variable e associated with our math class. That's what it means for it to be static. It means it's kind of, in a way, you can kind of think of it as being global, but it's global and it's accessible in the math class. It's a double, so we know it's a fractional component. It's final, so once it has been set, it can't be changed. It's static, so there's only ever going to be one chunk of memory that's reserved to keep track of it. When we create new math objects, we'll just use that one chunk of memory over and over again, and it's public so that anyone can use it that wants to use it. We're combining two different reserved words, two different decorators here, static and final, to help describe how this variable can be used. So these are some that are available to us. Let's see if we can access them easily here. So maybe in our code down here at the bottom, let's see, where do we want to put it? Let's say b is going to equal to math.pi. There we go. So we're able to represent our constants symbolically. And what we've done here is, in order to get to the static variable, we've used the class name. Notice we didn't instantiate anything. We never said math equals new math. Haha, new math. That's kind of funny. And then do math.py. We didn't need to do that because it's static. We don't need to instantiate a new object to get access to static bits. We can just use it directly with the class name. Alternatively, we could do b equals math dot, what else do we have? We have e, and you can see that I get suggestions of what things are available to me that are static here. And it looks like you just got 2 static variables in the math class, but a lot of other functions as well. When I type it in, you can see that I get a little bit of indication of what it is. The fact that it is blue means it's final, and the fact that it is italicized means that it's a static constant. Right, so we can use it directly, or we can use it in our code. So if we want to use it directly, we can use it the way I just showed you in Eclipse, or you can use it as part of an expression as well. Okay, so just to summarize, the way we can specify constants. We use a convention of using uppercase letters, but we enforce it with the reserved word final. Those 2 things help to communicate both to the compiler and to other programmers what this thing is. We give it a type, we give it another decorator static if we want only 1 copy of it in our code, and then public if we want anyone to be able to use it. Questions or comments? Okay. All right, so let's take a look at a particular version. Let's see, we've got 10 minutes left. I kind of feel like this is. All right, let me just go in game here for a sec. I'm gonna stop broadcasting. Through arithmetic operators, they're the same as we've got in other languages. So we've got addition, subtraction, multiplication, and division, and we have parentheses. The order of operations is double broadcasting. The order of operations is basically the same as in Python. No major things that I flag as being different. My same philosophy is I use the same philosophy as I do in Python, which is to overuse parentheses rather than relying on my knowledge of order of operations and getting it wrong and then getting a calculation error. That's sort of screwy. So here's an example of the way in which parentheses can control whether you do an addition first or a division first. In the middle yellow box, we're going to do our addition first and then do the division. And in the bottom yellow box, we're going to do our division first and then we're going to do our addition. I don't like monkeying around with all those sorts of like really subtle errors. So I just put in parentheses and I'm very clear if I need to do an expression first or later. And I will also introduce new variables. For example, I might break this down into another variable called numerator, which is a plus b, just to make it very clear how I want the calculation to proceed. It's not like it costs a lot in efficiency or anything, and it just reduces the errors that you make, which is far more likely than running out of efficiency. If at any point we mix literals, we mix an integer literal type and we mix a floating point literal type, Java's general tendency is to upgrade it to the version, to convert it to a floating point. Basically just converts it to a floating point because it's more likely that it's able to represent the answer as a floating point. So if we take 7 as an integer, add it to 4.0 as a floating point, Java does know how to add those together, but the result will be a floating point. You just have to be careful about those things because they're a place where errors are introduced. Okay, we have some shorthand operators. If we want to increment or decrement a particular variable, we can use the plus plus operator or the minus minus operator. So if you look at the second bullet here, we have a variable called counter, and we use the plus plus after it, and that's going to add 1 to counter. It's shorthand for saying counter equals counter plus 1. The fourth bullet is shorthand for saying counter equals counter minus 1. Just syntactic sugar. It's helpful to know. Use it all the time. All right, a slightly different way in which integer division and remainders work in Java. So when we do division, division is basically what you expect as long as one of your numbers is a floating point number. You'll get a floating point result. So the first answer, for example, is 1.75. The second is 1.75, and the third one is 1.75. But there are 3 examples here in that second bullet point because there's actually 3 different expressions happening. 7 as a double divided by 4 as a double, 7 as an integer divided by 4 as a double, 7 as a double divided by 4 as an integer. Because of the way Java upgrades, the way Java casts all mixed expressions to floating points, you're going to get the same thing in all those cases. But look at that second high-level bullet, 7 divided by 4, where both of those are integers. Because they're both integers, the numerator and the denominator, that's going to get evaluated to 1, not 1.75. The result of dividing an integer by an integer is an integer, and we throw away the fractional remainder as a result. And so, again, you have to be careful about this when you're coding, that when you type in a literal, you're clear about whether you intend Java to treat your number literal as a floating point or an integer, because you can get different results from your math operation. If you do want that fractional component, then you can kind of get it with the modulo operator. This is the same as in Python, where if you do 7 modulo 4 using the percent sign, what you get is an integer result, but it's the remainder of 7 divided by 4. So a combination of 7 divided by 4, an integer expression, and 7 mod 4 as an integer expression as well, gives you enough information that you could calculate 1.75 if you wanted to, but by dividing 3 by 4 in the bottom one. All right, modulo is a really valuable operator to be able to use. Takes a little while to get your head around it and to understand when you use it. It's very tightly interlocked with some theoretical algebraic concepts of rings and groups, things which are why I don't teach math. Okay, here's an example of why we want integer division and remainders, because we might want to calculate the like dollars and cents like we were doing in our amount class. If we have a certain number of pennies and we want to see how many dollars they are, we could do pennies divided by 100, and then we could say cents equals pennies mod 100. So this is an alternate way of doing the code that we did before. So this would be a great moment to go back and adjust our amount class. So let me go ahead and do that. This is a good opportunity. Calling an audible here. So I'm going to switch over to our Eclipse code. Let me give us the full example here. We've got our demo class, but what I'm going to do is I'm going to take the code from our last class, which was all of the amounts and the bank accounts. I'm going to select it. I'm going to copy it. I'm going to select the source folder in today's class, and I'm going to paste it. It'll ask me to save the current version of demo. And now I've got all of these classes in a particular spot. I'm going to go ahead and put them in a package because now we're getting enough code that I want to be careful about where it's ending up. So I'm putting amount in the package, or I'm typing the package indicator in the code. Eclipse says, wait a second, this file isn't actually in that package. So I'm going to say, hey, please move the amount to that package, and you'll see over on the right, the folder hierarchy will get updated to reflect what's in my source code. Now you can see that my account class has been put into the proper package and the proper folder hierarchy. Firewall's complaining. And I'm going to go ahead and do the same thing as what I just did to amount, but instead of typing it into the file, I'm going to select those. I'm going to select here. I'll open one up so you can see what happens here. Here's amount.test. You can see there's no package declared here. And what I'm going to do is I'm going to drag them into this package, and you'll see that the package gets declared automatically for me. I've got a few problems here associated with the fact that I don't have a JUnit. I don't have JUnit as a runtime, so I'm going to go under select my project. I'm going to go under properties, go under Java build path and libraries, and I'm going to add the JUnit library so I don't have that complain. Add the JUnit library, and I'm going to add the JRE system library to my class path so that I'm not using modules, because you know how I feel about modules. Apply and close. And I should see that. Yeah, there we go. Great. All right, so the reason why I did this though is because I wanted to alter amount. And I wanted to alter it using our examples of modulo and division. So in particular here in this update class, remember what we did is we created a loop where we would subtract 100 from our cents each time in order to update our dollars. So instead of doing that, what we could do is we could implement it in a different way. Here's an example of me changing the implementation, but because I have very clear examples of my interface, no one that wrote code against this method has to change what they wrote. But what I'm going to do is I'm going to say this dot dollars plus equals, so I'm going to increment it by this dot cents integer division 100. And then I'm going to say this dot cents equals this dot cents modulo 100. So rather than doing a loop, this is going to be much more efficient. You can imagine that if this dot cents was like a billion, and I had to do this loop a billion divided by 100 times because each time I was subtracting 100, it would take a long time. Instead, I've converted it to an integer division and a modulo so that it happens in 2 lines no matter how big cents is. It's kind of a corner case, but it's still something helpful. Now the question is, did I get this math right? Did I get the right answer? Did I do the right thing? How do I know? Well, I can write a test, but I don't need to write a new test. I already wrote a test against the correct behavior, and this is why it's called a regression test, because it makes sure that if I implement something, I don't regress and introduce an error that I previously didn't have. So I'm not 100% sure I got this right, so let's go ahead and run coverage as a JUnit test on my amount test class. We'll run through, see how we do. Great, we passed everything. And you can see that we ran a bunch of tests because I'm looking at code coverage that cover all the functionality. So this is great. I was able to update the implementation of my class using some things that I learned that are much more efficient than what I had before, because instead of doing a loop and doing a bunch of subtract by 100s over and over again, I'm just doing an integer division and a modulo. I made my code faster and more explicit, and anyone who used the update method doesn't have to change their code. For example, the test that I wrote that tested the update method, it has the same behavior now. So that is a win. Yay. That is a win for teaching and a win for software engineering, because that was an audible. I did not plan for it to happen. Okay, that brings us to the end of class. And scanning real quick, looking in Slack, I got a class. Okay, Taylor, stick around and let's fix our VPN credentials. You should have them. That was coming up in Slack. Any other questions before we dismiss for today? What do you got? You're welcome. Okay, thanks. This has been February 3rd, Wednesday. I'm stopping the stream.